Welcome aboard. I'm Captain Wayne Canning, and in this video I'm going to be talking about inverter installations. Inverters are a great way to get AC power while away from the dock and shore power. Although most inverters cannot run high demand appliances such as air conditioning or heating like a generator can, they are great for low power uses such as computers, televisions, and small appliances. Granted, there are some inverters with bigger battery banks that can run heavy loads, but the bulk of installations on your average boat is around 2,000 to 3,000 watts. The ability to chill out in a quiet anchorage and still be able to use your computer and perhaps a blender without the noise of a generator is a nice thing indeed. Inverters operate by converting DC battery power to AC power. They do this by converting the straight positive and negative DC power to alternating current as found in most homes. Another nice thing about inverters is that once installed, they are relatively maintenance-free and can provide years of reliable service. A good installation, however, is important to both good performance and onboard safety. As a marine surveyor, I get the opportunity to look over many inverter installations. Surprisingly, very few are installed correctly, even when the installation was done by professionals. I do not think this is a lack of care on the installer's part, but rather some common misunderstandings as to how an inverter should be installed to be both safe and reliable. At first thought, an inverter installation would seem pretty straightforward. Hook it up to the batteries and plug in an appliance and it's ready to go. Of course, nothing is that easy on a boat, and the more one gets into the finer points of the installation, the more there is to consider. For a simple single supply inverter powering a single appliance or outlet, the installation can be fairly simple. There are a few basic safety considerations that are important but easy to accomplish. It is when larger inverters over a few hundred watts are connected to the boat's main power panel that things get a bit more complicated. But even that is not that hard to do right. When using small portable inverters, care needs to be taken if plugging into the round cigarette lighter type outlets, now commonly referred to as power outlets. These outlets are designed for peak loads of up to 15 amps. This can be a bit deceiving because many of these outlets cannot carry those loads for extended periods. To make matters worse, many boat builders and aftermarket installers do not always run large enough wires to these plugs. Even small inverters can put a heavy load on these outlets. A small 150 watt inverter will draw close to 15 amps when fully loaded. This can create a potential for overheating or a fire risk. Even a small inverter load for an extended period of time can damage these types of plugs and outlets. For any inverter larger than 100 watts, it is best to go with a permanent installation, or at least have a dedicated 12-volt outlet capable of handling heavier loads for an extended period. Inverter installations require connections to both the DC and AC systems of the boat. It is important to follow the manufacturer's recommendations for wire size based on load and distance from the batteries. A Class T fuse, which is faster acting, should be installed on the DC positive conductor at the power source, usually the battery, to protect both the inverter and power conductors. This fuse should be located as close to the power source as practical. ABYC recommends 7 inches, but anything less than a foot should suffice. It is always best when the inverter can be located as close to the batteries as possible. A power disconnect switch should be installed as close to the power source as possible after the fuse. The reasons for having a switch are twofold. First, it is important to be able to quickly disconnect power to the inverter in the event of a fault that does not blow the fuse. The second reason is that it is important to fully disconnect power to the inverter when working on any AC circuits supplied by the inverter. Many inverters have a sleep mode, and as long as it has DC power, it can produce AC power. In sleep mode, the AC power may not be detectable with the meter, but will come on with a heavier load applied. This can be a shock hazard to anyone working on the electrical system, as they may think the AC power is off, only for it to come on when touched. A ground wire also needs to be installed to the inverter case. This ground wire is needed to protect the unit and circuits from both AC and DC faults. In most installations I see, this ground wire, if installed at all, is the same size as the AC ground wire. At first, this would seem to make sense. However, this ground wire needs to be capable of handling a DC fault as well. This means it needs to be the same size as the DC conductors connected to the inverter. This ground should ideally be run directly to the batteries or engine ground. Sometimes it might be shorter to run it to a ground bus, but care needs to be used to make sure the ground bus is fed by a wire of at least the same size or larger. Once the DC power supply is set up, it's time to think about the AC side of the inverter, and this is where things can get a bit more complicated. All inverters, except for small portable units with built-in outlets, will require AC output wiring. When using smaller portable inverters or any inverter with a built-in AC outlets, make sure the outlets are GFIC type to further protect you from shock hazards. This is also an ABYC requirement for marine inverters. Some inverters have an automatic transfer switch or relay to transfer output power from the shore power or generator power to the inverter output should AC input power be lost. This feature allows the inverter to be a reliable backup power source and an offline power source. Inverter chargers and inverters with automatic transfer switches will require both AC input power and AC output wiring. The input power supply should originate at the main AC panel and be heavy enough gauge wire to handle the full inverter or charger load and any load that might be passed through the inverter. Some inverter chargers can charge batteries at rates as high as 200 amps or more. This translates into 2400 watts or 20 amps AC draw. Keep in mind that on a 30 amp shore power supply, this would amount to 2/3 of the available power. This is more than most think, so it is important to use a wire size that will carry this load. Depending upon the length of the run, this would likely be at least a number 10 or number 8 wire, but this should be calculated based on the length of the run and potential loads. This power supply must have a double pole breaker at the power source. If the supply to the inverter is off the main panel and after the main shore power breaker, a single pole breaker on the hot lead will suffice. The green ground wire is run direct to the inverter and should never have a switch, fuse, or breaker in it. If a ground isolator is used, this would be on the shore power side before the panel and should not affect the inverter or its ground. With the input supply worked out, it's time to think about the inverter output. The first thought most have is to simply connect the inverter output to the main AC panel power input. But it is, of course, not that simple. If the inverter does not have an automatic transfer switch, a manual transfer switch like those used with a generator will need to be fitted. This is required to prevent back feeding of power to either the inverter or the shore cord. The loads the inverter will carry will also need to be considered. I see many installations where the entire panel load can be placed on the inverter. This could lead to problems with overloading of the inverter or rapidly discharging of the batteries. Some owners claim they are just careful to turn off heavy loads prior to energizing the inverter. This sounds good in theory, but if you have an inverter with an automatic transfer and lose shore power while away from the boat, you could have problems. Even without the auto transfer, mistakes can be made and overloading the inverter is a real possibility. True, most inverters will shut down with low battery voltage, but these sudden heavy loads could damage otherwise sensitive electronics and place unnecessary loads on the DC system. A better approach is to separate the loads that will only run from the inverter from the heavier loads, such as air conditioning, water heaters, and battery chargers. This will prevent these heavier loads from accidentally being placed on the inverter. Because most hardwired inverters are primarily used to power AC outlets, lighting, and other light loads, it makes sense to separate these loads from the heavier loads. On most AC panels, the lighter loads, such as outlets, are often grouped together, making this task easier. Often, separating these groups can be as simple as cutting the power bus bar on the back of the breakers. Sometimes this may require regrouping breakers, but this is usually not a hard job. Another option is to just add a small branch circuit or sub-panel that will allow the inverter to power a few AC outlets. This is a simple approach, but it has to be kept in mind that you still need to use breakers for each circuit. Any inverter supplied outlets should also be GFIC type or on a GFIC protected circuit. Care needs to be used installing GFIC outlets, as not all GFIC outlets work with all inverters. Check with the inverter manufacturer regarding the use of GFIC outlets and use the type or brand recommended, and be sure to test that they work properly once installed. It is also important to have the AC neutral or white wires for each power source separated from the other power source neutrals. This is a common error found in many inverter installations. As an example, if you have two shore power cords, each cord or inlet will have a separate neutral bus bar, and only circuits powered from that shore cord or inlet would be tied to its neutral bus. Adding an inverter would be like adding a third outlet, in that you would also have a separate neutral bus for just the inverter loads. This is done to prevent faults from backfeeding through the neutral bus to other power supplies or equipment. The neutral wires are normally tied to their bus bars at or near the main AC panel. Any loads being powered by or through the inverter should likewise have their own neutral bus, separated from the other power source neutral buses. It is important to do this for safety and to prevent problems with possible galvanic corrosion. While installing all these wires and connections, it is important to follow basic ABYC and marine practices for electrical wiring. Secure all wires out of the way from damage and from stowed equipment. Neatness counts when running wires. When making connections, use good quality crimp type connectors. Never use screw-on wire nuts as commonly found in houses. Use properly sized ring terminals for screw connections, and make sure all connections are tight and protected from shorting. Use good quality marine wire. Solid strand wire, often found in many home repair stores, is not approved for marine use and should not be used. When installing any inverter, it is important to know when the inverter is on and whether it is producing power or in standby mode. Most marine inverters will have remote control panels that have an indicator light showing their status. With smaller and particularly non-marine units, indicator lights may not be available. For safety, it is important to know when your AC power is available, so some method of knowing the inverter is online is important and required. Finally, consider the physical location of the inverter before installing it. You want the inverter to be installed as close to the power source as possible to reduce the length of conductors and reduce voltage drop. The inverter should also have good ventilation to aid in the unit's cooling. Many inverters will produce a fair amount of heat when operating. It is, of course, important to make sure no water gets into or onto the inverter as well. This means installing in a dry location away from any possible deck leaks or leaks from plumbing. Although some of this may sound a bit complicated, it really is not if you take it one step at a time. Following the above guidelines and the inverter manufacturer's instructions will help ensure a safe, reliable installation. If you already have an inverter installed, it would be wise to review the installation to make sure it meets all of the requirements outlined. Even if only using a small portable inverter, it is important to make sure the power supply is properly fused and capable of maintaining the inverter load. A proper earth ground to the inverter case is required as well, even with small portable units. Without this, you or your crew could become a path to ground, a hazard that is easily avoided. Inverters can be a great source of quiet AC power while away from the dock, but likewise they can pose the same hazards as shoreside AC power if not set up properly. A little care and effort with the installation will help keep you and your crew safe while enjoying the benefits of quiet AC power. For more information, please visit my website, boatingzen.com. There you will find a PDF copy of a complete wiring diagram of a typical inverter installation. This may help guide you along your path as you install your inverter. Thanks for watching. Let me know if you have any questions, and remember, the fun never stops when you own a boat. Thanks for watching. If you found this video helpful, please consider signing up to my Patreon page. Every little bit helps. It takes a lot of time to make these videos, actually probably about 1 hour per minute of video. And the equipment costs money as well. So your support on Patreon will help me keep producing new and better videos. Thanks a lot.